Hello math lovers, welcome to the channel. This will be a video on coordinates geometry. So the question is, there is a circle in the xy plane with its center at the point C equals to A and B and radius 6 units. If A and B are integers, how many points with integer coordinates do not lie outside the circle? So here in this diagram you can see the xy plane. This horizontal line is the x-axis, whereas this vertical line is the y-axis, and this is the center O of the xy plane. Now it is given in the question that we have a circle with the center C as A and B and its radius is given 6 units. Now since the center C of this circle has variable coordinates A and B, so this circle can lie anywhere in this xy plane, but for our simplicity we'll bring the center of this circle to the center of this xy plane. That means O equals to C, and the coordinates will be A equals to 0 and B equals to 0. Now we know it very well that given the radius 6 units of this circle, if this circle is shifted anywhere in the xy plane, then there will not be any change in the number of points inside and on the circle. So the equation of the circle will become x square plus y square equals to 36. The question given to us is how many points with integer coordinates do not lie outside the circle. This means that how many integer coordinates lie inside or on the circle. So keeping this in mind, our equation will be x square plus y square smaller than equal to 36. So this will help us find all the points inside the circle. So there may be infinite number of points within this circle, but the question is interested in only the integer coordinates that lie inside or on the circumference of this circle. So to find out all the integer coordinates that lie within this circle or on the circumference of the circle, we first consider y equals to 0 as the diameter of this circle. Then we draw 6 horizontal lines above this y equals to 0 line. Because the radius is given 6 units, so we have 6 lines. So these lines are y equals to 1, y equals to 2, y equals to 3, y equals to 4, y equals to 5 and y equals to 6. So each of these horizontal lines are 1 unit away from its surrounding lines. Thus all our y coordinates are integers. Now we need x coordinates that are integers. So we need to know how many such x coordinates are there in each given horizontal line. Each x coordinate represents a point. Thus we will know how many integer points are there in each of these 6 y lines. So let's find out all the integer points within and on this circle. For this we put the integer values of y in the equation x square plus y square smaller than equal to 36, and we'll get the value of x that will cover all the points from the x-axis to the circumference of the circle. We will then pick up our required integer points. For example, if we put y equals to 1 in the equation x square plus y square smaller than equal to 36, then we'll get the value of x equals to plus minus 5.91. So if we consider minus 5.91, that means that minus 5.91 represents this point on the circumference of this circle. So there are 5 integer points on the left of y-axis and 5 integer points to the right of y-axis and 1 point on the y-axis. So that means that there are a total of 11 points on y equals to 1 line. So let us see all the points on each of these y lines. So you'll see that we have worked with all the 6 y lines here, and we will see them step by step. So this y equals to 0 is the diameter. If we put y equals to 0 in our equation, then we'll get the value of x smaller than equal to plus minus 6. So on the diameter there are 6 integer points to the left of the center and 6 points to the right of the center and 1 point on the center, a total of 13 points. Then we'll move above the diameter and we will put y equals to 1. So if we put y equal to 1, x will be smaller than equal to plus minus 5.91. This implies that there are 5 points to the left, 5 points to the right and 1 point on the y-axis, a total of 11 points. If y equals to 2, x will be smaller than equal to plus minus 5.65. That implies that there are again 5 points to the left, 5 points to the right, and 1 point on the y-axis, again a total of 11 points. Similarly, if y equals to 3, then we have the value of x smaller than equal to 5.19, again the same, we have 11 points. Likewise, if we have y equals to 4, then the value of x will come out as x is smaller than equal to plus minus 4.47. so this 4.47 represents the point on the circumference. So if we have to pick up integer points, then we have 4 integer points to the left of the y-axis, 4 integer points to the right of the y-axis, and 1 point on the y-axis, total of 9 points. So if y equals to 5, we have x smaller than equal to plus minus 3.31. this implies that there are a total of 3 plus 3 plus 1, 7 points. And finally, if y equals to 6, then x will be smaller than equal to 0. That means there are no points to the left and right of the y-axis. There is only 1 point on the y-axis, so we have 1 point. We see that there are a total of 11 plus 11 plus 11 plus 9 plus 7 plus 1, that is 50 points above the x-axis. So these 50 points are inside or on the circle above the x-axis. Similarly, there will be 50 points below the x-axis also. As I have already discussed, there will be 13 points on the x-axis. Thus, there will be a total of 50 plus 13 points on the x-axis, a total of 113 points. Therefore, the total number of points with integral coordinates not lying outside of the circle are 113 only. So now, having found our answer as 113 points which do not lie outside of the circle, so now let's go to the proof. So we see that on this y equals to 1 horizontal line, we have 1, 2, 3, 4, 5 points to the left of the y-axis, and 1, 2, 3, 4, 5 points to the right of the y-axis, and 1 point on the y-axis. So a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. So there are 11 integer points on y equals to 1 line. Similarly, there are again 11 points on y equals to 2 and y equals to 3 lines. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And in y equals to 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In y equals to 4 lines, there are 4 points to the left of the y-axis and 4 points to the right of the y-axis and 1 point on the y-axis. So there are 9 points on y equals to 4 line, and in y equals to 5 line there is 1, 2, 3, 4, 5, 6, 7 points, and there is only 1 point on the circumference on y equals to 6 lines. So there are a total of 50 points here on y equals to 1, 2, y equals to 6 line. And on the diameter, that is y equals to 0 line, there are 13 points. 2 points are on the circumference. So we see that 1, 2, 3, 4, 5, 6 points here, and 1, 2, 3, 4, 5, 6 points here. So 6 and 6, 12, and 1 point in the center, 13 points. And we can clearly see that there are 50 points here. So there will be 50 points here because there is a very good symmetry in a circle. So 50 plus 50 plus 13 will give us 113. So it is practically also proved that there are 113 points inside or on this circle when the radius is given to us as 6 units. Answer. Thank you, and if you think you like my explanation, then you can press that like button. You can also press that subscribe button if you think that you like most of my videos. If you have not seen many of my videos, then you can go to my playlist and enjoy my other videos. If you have any doubt in this video, then you can comment me in the comment box and I will help you clear your doubt. Thank you.